Alright, so in this equation, I'm going to be solving 9 to the power of x is equal to 36. So to start, my variable in this equation is x, which is what I'm going to be solving for. And we can already tell that x is not going to be a whole number because 9 to the power of 1 is 9 and 9 to the power of 2 is 81. So we know that x is going to be somewhere in between 1 and 2. So we want to find the exact value of x. So to do that, what I'm first going to do is take the log on both sides. So I get log 9 to the power of x is equal to log 36. And the reason I used logarithms for this is because they have a special property that states that if I have something in the form log a to the power of b, I can move this exponent b to the front, so this turns into b times log a. So before, x was an exponent, and it's almost impossible to solve the equation just in the form x is. But now we can move x to the front and make it equal to a whole number, and now it's much easier to solve for x. So now I get x times log 9 is equal to log 36. And now, obviously, we want to isolate x, so I'm going to divide both sides by log 9. So then these two cancel out, and I get x is equal to log 36 over log 9. Now, we aren't done yet because we want to find the exact value of x, so we don't want any logarithms in our solution. So now what I'm going to do is I'm going to rewrite log of 36 as log of 9 times 4 because I just want to simplify log 36. And now I can use the property that states that if I have something in the form log a times b, this is equal to log a plus log b. So in this case, I have log 9 times 4, and we can say that a is 9 and b is 4. So this turns into log of a, which is 9, plus log of b, which is 4. And remember, I still have all of this over log 9. Now, if I have something in the form a plus b over c, this is equal to a over c plus b over c, and this is just using fraction properties. So I have log 9 plus log 4 over log 9, and I'm going to rewrite this as log 9 over log 9 plus log 4 over log 9. Now, anything over itself equals 1, so log 9 and log 9 cancel out, and I get 1 plus log 4 over log 9. Now from here, I'm going to simplify this by rewriting log 4 as log of 2 squared, because 4 is equal to 2 squared. And I'm going to do the same thing to log 9. I'm going to rewrite it as log of 3 squared. So now remember that if I have something in the form log a to the power of b, this is equal to b times log a, because I can move b to the front. So I'm going to be reusing this property on these two terms. So log 2 squared, I'm going to move the 2 to the front. And same with log 3 squared, I'm going to move the 2 to the front. So I get x is equal to 1 plus 2 times log 2 over 2 times log 3. And now I can cancel out these 2's. So I get x is equal to 1 plus log 2 over log 3. So now from here, log of 2 is equal to 0.3010, and log of 3 is equal to 0.4771, meaning x is equal to 1 plus 0.301 over 0.4771, which is equal to 0.6309. So 1 plus 0.6309 is 1.6309. So this is my solution. Alright, so in this problem, I have 81 to the power of x is equal to x to the power of 18. So I want to find the value of x here. So for my solution, I'm going to rewrite this equation. So 81 to the power of x is equal to x to the power of 18. And now, I'm going to take the power of 1 over x on both sides. So I get 81 to the power of x to the power of 1 over x is equal to x to the power of 18 to the power of 1 over x. And now if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 81 to the power of x times 1 over x is equal to 81 to the power of 1, which is the same thing as 81. So I get 81 is equal to x to the power of 18 to the power of 1 over x. And x to the power of 18 to the power of 1 over x is the same thing as x to the power of 18 times 1 over x, which is the same thing as x to the power of 18 over x. Now I'm going to take the power of 1 over 18 on both sides. So I get 81 to the power of 1 over 18 is equal to x to the power of 18 over x to the power of 1 over 18. And this is the same thing as 81 to the power of 1 over 18 is equal to x to the power of 18 over x times 1 over 18, and these two 18s cancel out, so I get 81 to the power of 1 over 18 is equal to x to the power of 1 over x. Now, 81 here is the same thing as 9 squared. So I'm going to rewrite this as 9 squared to the power of 1 over 18 is equal to x to the power of 1 over x. And now this is the same thing as 9 to the power of 2 times 1 over 18 is equal to x to the power of 1 over x. And 2 times 1 over 18 is the same thing as 1 over 9. So I get 9 to the power of 1 over 9 is equal to x to the power of 1 over x. Now, notice how this is in the form a number to the power of 1 over that same number is equal to x to the power of 1 over x, meaning x is equal to this number 9. So now, going back to the original equation, let's go ahead and check if this is right. So I have 81 to the power of x is equal to x to the power of 18. So x is equal to 9. So if I plug in 9 for x, I get 81 to the power of 9 is equal to 9 to the power of 18. Now, 81 is the same thing as 3 to the power of 4. And 9 is the same thing as 3 squared. So I get 3 to the power of 4 to the power of 9 is equal to 3 squared to the power of 18. And if I have something in the form a to the power of m to the power of n, that's equal to a to the power of m times n. So 3 to the power of 4 to the power of 9 is equal to 3 to the power of 4 times 9, which is 3 to the power of 36. And this is equal to 3 to the power of 2 to the power of 18, which is equal to 3 to the power of 36 as well. So this is right.